Assalamualaikum warahmatullahi wabarakatuh. So today we are going to learn about transmission and distribution of electricity. Okay, last time we have talked and discussed about transformer, and you have learned about step up transformer, step down transformer, and you know the function of a transformer. Okay, functions of the components in the electricity transmission and distribution system. So today we'll be looking at the functions of each component in the electricity transmission. Okay, so electricity is transmitted and distributed. Ataupun dalam bahasa Melayu kita kata tenaga elektrik Okay, diagram shows the electricity transmission and distribution system that connects a power station to your house. Alright, so let's look at this. Right, so this is the big picture of what is happening every day, actually right now. Okay. So the generators at power station, so it starts here. Okay, starts here. Okay, generators at power station produce alternating current AC with a voltage of 11 kilovolt or 25 kilovolt. Okay, so these are generators. And then alternating current AC, remember we talked about AC last week, from the power stations is then transmitted to a step-up transformer. So here there is a step-up transformer. Okay, we call that station BN, for example. Okay, we use this symbol. This symbol shows here we have a step-up transformer. Okay, here the voltage of the alternating current is increased to 132 kilovolt, 275 kilovolt or 500 kilovolt using step-up transformer. Okay, so here we have step-up transformer. Then what happened? Okay, so the electricity is transmitted, and now it reaches transmission through long distances. Okay, now here are, okay, if you look at this diagram, the high voltage here the high voltage alternating current, remember just now we have stepped up the current. Okay, now here we still have current with a very high voltage. The high voltage alternating current is then transmitted through a network of transmission cables called the National Grid Network. So we use this symbol C, okay, as shown in the photograph below. So have you ever experienced or traveled around in Malaysia, and have you ever seen these? Okay, so this is an example of National Grid Network. So for this first diagram, 500 kilovolt alternating current transmission cables along the north-south highway. Okay, if you use plus, you may see these. And then this one, an example of 132 kilovolt alternating current transmission cables in Malacca. Okay, I believe you have seen this, right? So this is the National Grid Network. Alright, so now the current continues until it reaches at the end of the grid. The alternating current flows to a switch zone. So we have a switch zone here. It's D at the main substation. So this is a main substation. In the main substation, we have a switch, right? This switch zone enables electricity to be sent to the branch substation when needed. Okay, this switch zone is also used to enable specific power stations and grids to be closed for maintenance works without disrupting the electricity supply to consumers. Okay, do you understand that? So we can switch it on, we can switch it off. Okay. So if we need to maintain, we need to do some improvements to the power station, we can switch it off. Okay, and with this switch zone, okay, the maintenance work will not disturb us. Okay, so although TNB is doing, for example, maintenance work at home, we still receive electricity. Okay, this is an example photograph showing a main substation. So this is an example of switch zone. We can see switches here. Okay, so from the main substation, okay, the electricity will go to heavy industrial area, or then maybe to light industrial area, or it can reaches us, okay, to the consumers. So we are consumers, consumer. Okay, now here at the main substation as well, okay, we have branch substation E2. Okay, so the alternating current is transmitted through a series of step-down transformer. So we have transformers here and also here. Remember the function of a transformer? And remember just now we have stepped out our electricity. Now when the electricity will be distributed to the consumers, which is us lah, you, okay, the high voltage electricity must be stepped down. Okay, so here we have step down transformers. Okay, the voltage of the AC is reduced gradually to different voltage values to be supplied to consumers according to our needs. Okay, so these are examples lah. Okay, for heavy industrial area, maybe we need 33 kilovolt, but in light industrial area, we just need 11 kilovolt. Offices, business, schools, residential areas, we need only 240 volts. Okay, okay, so this one is small ya. This is only 240. Kalau yang ni dia ada kilo kat situ. Do you still remember you learn about prefix? Kilo means 1000. Okay, the 1000 means this one meaning 11,000. Ada 11, ada 3 lagi 0. 11,000. Jangan lupa ya. This one nampak macam kecil dan 240, no, but because this one ada kilo, kilo is prefix. Okay, recall balik belajar tentang prefixes. Okay, now this one also ada transformer. Step out, step down just now. Step out, step down. Yes, step down, because just now we have stepped up the electricity. Now we need to step it down. Step them down. Okay. Now, okay, these are the examples. So this is what we call as electricity transmission and distribution system. Okay. And then, right, we will look at impact on residences located near the National Grid Network pylons. Okay, if you go to the National Grid Network, okay, below the pylons, you will see fields, empty fields. Okay, if you don't think through, You may think you can buy the land down here and build your house. You may want a very huge house, and then you build under the pylon. Is that all right? What is wrong with that? What's the problem if you build your house under these pylons? Okay, actually, high voltage alternating current is transmitted through transmission cables. So here are the cables. If you look at the diagram, the picture. So the cables transmit electricity, and the electricity is very high voltage. And the electricity is AC, or alternating current. A strong electromagnetic field is produced by the high voltage alternating current and can be detected in the surrounding areas close to the pylons. Okay, so if you build your house down here, you may be what? How do you see that? You will be exposed. You will be exposed to a strong electromagnetic field, which is harmful. Okay, so do you still remember we learned about electromagnetic field? Electromagnetic. Okay, when we have a conductor and then current flows through the conductor will be a temporary magnet or electromagnetic. Okay, so electromagnetic field will be built up, will be building up lah. Right, now I want you to discuss this with your friends next to you and write down your ideas or your discussion together with your friends in the notebook. Okay, now do you know you can observe the effect of this electromagnetic field by using a compass? Okay, so imagine that you have electromagnetic field, strong electromagnetic field, and I give you a compass. What do you think will happen to the position of the compass needle when you place it in the field? What do you think will happen to the needle? Discuss with your friends and write your answer in your notebook. So by now, you may have written what is important we have learned so far. Okay, don't forget to update your notebook. Okay. Now we have reached to activity 6.7. Okay, I want you to look at your watch now. Spend 5 minutes to discuss the impact of the National Grid Network pylons on nearby residences. So look at this diagram here. Okay, I obtained this from the textbook, Form 3 Science textbook. So in the photograph, residences located near a National Grid Network pylon. So work in group, gather information related to the issues of the impact on residences located near the National Grid Network pylons as follows. You may find information about the strength of electromagnetic field close to the National Grid Network pylons. Then you can Google or you can find out or search about the impact of electromagnetic field on human health perceived by locals and confirmed by medical experts. Okay, maybe you will find, maybe you can find discussions about these from residences. Okay, you can Google this one. And ways to solve the issues regarding the electromagnetic field on residential areas close to the National Grid Network pylons. Okay, so once you have got all the information, I want you to write down these neatly in your notebook. Okay, right. So please make it colorful, or you can use mind map, or you can use your own creativity to write this one in your notebook. Okay, I will check your notebook later on. Okay, right, you can pause the video now and get some informations. Okay, you can Google, and please talk to your friends and discuss about this. Right, I believe that you have a very good discussion with your friends. Okay, now let's continue about electrical wiring system in Malaysia. This may be something new to you. Okay, the electrical wiring system in Malaysia consists of two different types: one phase wiring, or sometimes we call single phase, and we have another one, three phase wiring. Okay, so if you look at this one, we have only green graph. Okay, this is phase 1. Okay, the single phase wiring is only suitable and stable enough for electricity usage not exceeding 10 kilowatt or 50 amps, such as in rural residential areas. Okay, so we have only one cycle. Okay, right, this one 10 kilowatt, this is power. The current is 50 amps only. But in commercial and industrial areas, for example dekat kilang-kilang, dekat shopping malls, okay, electricity usage is more than 10 kilowatt or more than 50 amps. So the three-phase wiring, which is more stable and reliable, is used. So we use this one in a heavy industry or in a commercial areas. Okay. The peak PPP shows the peak values. Now, electricity supply and wiring system in homes. Okay, so here is an example of electricity supply and wiring system in homes. Okay, I'm sure you have seen this one at your home. Okay, so I'm sure you are familiar with this object. Okay, yeah, you have this at your home, right? So this meter. Okay, so the meter is connected to live wire and neutral wire. Okay, so here it says electric wires from the main cable that are connected to homes are made of live wire and neutral wire. Okay, live wire is 240 volts, but neutral 0 volts. Okay, now and then we have main fuse box with one main fuse. Okay, pernah dengar kan ayah awak ataupun mak awak sebut tu tengok fuse box. Okay, remember. Okay, later we will learn about the function of a fuse. So this is electric meter. Okay, measures the total units of electricity used. Okay, so orang TNB akan datang, read the meter, and then later you will get your bill. Right, so here are a few boxes. Okay, this one, main switch. So the main switch controls the total current flowing through the circuit in the house. Okay, if let's say you move from your house, you will go to somewhere else, or let's say for example, maybe your mom will turn off the main switch. Okay, now, so next we have earth leakage circuit breaker, ELCB. Circuit breaker, break, potong, hentikan, breaker kan. Leakage is kebocoran. So this one breaks the circuit when too much current flows through it. Sometimes kan kalau kilat kuat sangat kan, putih, and then kita punya tiba-tiba tertutup. Okay, ni lah yang berlaku. Okay, miniature circuit breaker MCB separates the final circuit to different electrical appliances. So we have a few different colors. So here is the key. Live wire is red, neutral wire the blue ones, and we have green wire, which is earth wire, will be earth. Okay, so it is one. Look at this picture. Okay, small picture here. So if you have seen this one, this is actually earth wire. We are earthing earth wire. Okay, tadi from here continues. Okay, so the wires continues to the lamps, your fans, air conditions, and so on and so forth. Okay, so two-way switch. Okay, switch on, switch off, and then switches. Okay, so this is lighting circuit, for example. Okay, lighting circuit is made up of live wire and neutral wire. So we have live wire, and then lepas tu connected to neutral wire. Okay, and then we have power circuit. Power circuit is made up of live wire, neutral wire, and earth wire. Okay, so here are the sockets. So example of electricity supply and wire system in homes. So this is what we have at homes, at the hostel, okay, in your class, and also in the lab. Okay, where were we? Alright, so here. Now, okay, this is nothing new. You know this one. We have two types of plugs, 3-pin and 2-pin. So you have seen this one. So here are a few examples. Okay, here are a few examples. Okay, this one is in Hong Kong. India is like this. Okay, North America is different like this. Japan, we have two like this. Europe and Malaysia are almost the same as Hong Kong and British. Okay, now what's the difference? So 3-pin plug, electrical appliances such as electric kettles and irons obtain electricity from the sockets on wall through 3-pin plugs. However, for 2-pin plug, we have electrical appliances such as hair dryers, electric toothbrushes. Okay, any more examples? Sometimes night lamp, get light lamp kan, sleeping lamp. Okay, radio, small radios, use this 2-pin plug. Okay, the live wire, neutral wire, and the earth wire connected to 2-pin and 3-pin plugs are required to follow the international color code. So we have color code. So we need to use color code to ensure the safety of electricity use. So green, yellow, sometimes green yellow, sometimes all green, sometimes all yellow. Okay, this one is earth wire. And then we have blue one, neutral wire, and brown, live wire. Sometimes we have red. So this is fuse. Okay, fuse. Here is fuse. Okay. Next, safety components in the wiring system in homes. We have switch. So these are example of fuses. This one is just the one that we talked just now. Earth leakage circuit breaker. Kan, you switch this off, then everything will be switched off. And then miniature circuit breaker, ada small compartments, ada bahagian dalam bilik, ada bahagian dapur, ada kecil-kecil dah bahagi-bahagikan switch kecil-kecil. And then we have earth wire, and usually at homes we have lightning conductor. Okay, right. So now we look at fuse. Okay, so structure of fuse. Okay, this is fuse wire. And then kat luar ni dia ada badan dia tu filled with nitrogen or quartz particles. Metal contact cap. Okay, the value of a fuse, for example, 5 amps. And then also we have glass or porcelain casing. Okay, the glass or porcelain casing enclose the nitrogen and quartz particles. Okay, so the fuse structure is a fine and short wire that heats up easily. So this one a very fine wire. Halus je wire ni. So dia akan cepat panas lah bila dia halus. Okay, it melts when the current flowing through it exceeds the value of the fuse. So let's say here the label says 5 amps. So if you have current flowing which is 6 amps, so the wire will melt. Okay, or for example 5.5. So the wire will eventually melt. Okay, because it only allows current flow that is less or equal to 5 amps, cannot exceed than 5 amps. Okay. If the wire of the fuse melts, the electricity will be cut off. So this is to prevent danger. Okay, to prevent your electric component or your electrical appliances to be broken or on fire, whatever lah. Okay, so these are example of cartridge fuse and replaceable wire fuse. Okay, we have two types of fuses. So these are cartridge fuse. So it is placed in a casing. Okay, ada casing dia and tertutup, ada cap. And this is another example, and this is what we call as replaceable wire fuse. Okay, you can it can be replaceable. So the two types of fuses usually used are cartridge fuse and replaceable wire fuse. Okay, the replaceable wire fuse fuse is installed with a fuse wire. Okay, there is only a wire. All fuses function as electrical safety devices in circuits or electrical appliances to protect the wires and appliances from any excessive current flow. So hopefully by now you have updated your notes. Okay, write down what is important. Okay, now how do you determine the value of a fuse? So for example here, so this student asked a question. What is the maximum current that can flow through a 3-pin plug installed with a 13 amps fuse? Do you understand the question? If you don't, you may ask question now. Okay. Alright. So the value of a fuse is the maximum value of current that can flow through the fuse without causing its fuse wire to melt. So for example, a 5 amp fuse wire allows a maximum current of 5 amps to flow through it. Okay, so we have some common fuse ratings. Okay, so we have what is available in, we have 1 amps, 2 amps, 3, 5, 10, 13, 15 and 30. That's all. We don't have 2.5, we don't have 11, we don't have 16, 20 like that. Okay, choosing the value of a fuse depends on the value of the maximum current that flows through a circuit or electrical appliance. Okay, so the fuse to be used should have a value which is slightly higher than the maximum current that flows through a circuit or electrical appliance in normal operating condition. So for this question, for example, an electric kettle. Let's say we have an electric kettle. So the electric kettle has current flow which is 11.34 amps. So which one is suitable for the kettle? You cannot put 30 amps fuse because this will not prevent harmful event. Okay, kenapa? Yelah, because if let's say you the kettle only allows current 11.34, but suddenly ada leakage, ada kebocoran elektrik, and then current that is flowing is 13, for example 13 amps. So apa yang akan berlaku kalau fuse 30 amps? Okay, so the fuse will not melt. So what will melt? So the electric kettle yang akan lebur. So we cannot choose 30 amps. So which one is suitable? One tak boleh because this is too small, kan? Sekejap je dah terus lebur. You have to change the fuse every time you use. So the best or the most suitable one, the most suitable fuse will be 13 amp fuse. Okay, because it's not too high but not too small. Okay, choosing the value of a fuse depends on the value of the maximum current that flows through a circuit or electrical appliance. The fuse to be used should have a value which is slightly higher than the maximum current that flows through a circuit or electrical appliance in normal operating conditions. So I hope you understand what you have heard, what you learned. Okay, so if you don't understand, you can discuss with your friends next to you. Okay, please update your notes. Okay, now let's do this activity. Again, I want you to discuss the safety components in the wiring system in homes. Okay, work in groups. Okay, you can find your group member or you can just discuss with your friends next to you. Identify and discuss the following. First, functions, types and values of fuses. Okay, we have actually discussed this one. And then function of an earth wire, function of circuit breakers, namely miniature circuit breaker and earth leakage circuit breaker. Okay, you can Google in order to find this information. And finally, lightning conductor and switch. Okay, use various sources to gather the required information. So since we are now in the multimedia room, I want you to Google and you can divide the task with your friends. So maybe some of you can do function, types and values of fuses. Some of you may find the information for B, and some of you C and D, and then I want everybody to combine your findings. Okay, so you are going to write down the outcome of the discussion in your notebook. Okay, later we will think of about presentation. Okay, right, so we have reached safety in the use of electrical appliances. So look at the diagram. Okay, we have live wire, we have neutral wire, we have earth wire. The earth wire is connected to the metal casing of the electric iron. Okay, this is heating element. So this is a kettle. This is an example only. Okay, when using electrical appliances, safety measures should be prioritized. This is because the ratio of death due to the injury from electrical accidents is high compared to other categories of accidents. Okay, so this one is domestic injury. Okay, failure to adhere to safety measures will result in serious accidents or fire. Okay, one of the safety measures in the use of electrical appliances is shown in figure. When an individual touches the metal part that has been earthed, a large current flows to the earth through the earth wire and not through the individual. So this large current also melts the fuse, which then cuts off the electric circuit. Okay, so last time I think last month I watched in the news. Okay, ada the small kid was playing at the playground and he died. Kenapa dia mati? Dia mati meninggal sebab dia tak pakai kasut masa main dekat playground. Jadi what happened then? So suddenly dia terkena renjatan elektrik. So actually current it can be very harmful. So be careful every time. So that's why you are when you go out you need to wear slippers. Okay, jangan jalan kaki macam tu because we cannot see the current flowing. Okay, the current may flows in the earth kan. So budak tu mati meninggal macam tu sajalah sebab ada current dalam tanah tu. Bukanlah sebab playground kan, tanah, rumput semua tu. Okay, and finally this will be your homework for the weekend. Okay, I want you to create brochures or posters depending on your creativity on safety and electrical accidents. Okay, so work in group. I want the president divide everybody into 4 groups. So you will form 4 groups. Each group will do a poster or a brochure. Okay, so one group will have a brochure, will do a brochure about causes of short circuits. Another group will do about causes of electrical accidents, and another group about safety measures when using electrical appliances. And the fourth group will do steps to be taken when an electric shock occurs. So where to find information? Yes, you can read in the newspapers, you can ask your parents, you can discuss together among yourselves, you can go to the library and find any suitable books, or you can just use internet when you have the time to do so. Okay, discuss the information gathered, create brochures or posters. Okay, so next time next class I will ask for the brochures from you. Okay, you're going to present your brochures and posters. Okay, so let's answer the quiz. Quiz number 1. In a science class, Wazir learned about the components in electricity transmission and distribution system. Using the words given above, complete the following flowchart. This flowchart shows the sequence of the components in the electricity transmission and distribution system. Okay, so use this. Okay, we have 3 answers here, but you need to put the answers at the correct position. Power station to, and then to the national grid network, to the main substation, to to the branch substation, and finally to step down transformer. So now write your answers. Good. Okay, next question. Underline the correct answers. So you just write your answer. You don't need to write the questions. Write your answer only in your notebook. A. The voltage of the alternating current is before it is transmitted through the national grid network. B. The voltage of the alternating current is highest at the, and C. The enables electricity to be transmitted to the branch substation when needed. Write your answers now. Well done. Okay, we are not done yet. Next question. A. State 3 safety components in the wiring system in homes. Okay. B. What is the function of a fuse? Easy, right? If you can answer these questions, that means you have understood what we have discussed. Next question. Answer the question. Figure 1 shows several electrical appliances with their respective 2-pin plugs connected to a socket. Number 1. State the electrical condition as shown in figure 1. 2. Give one example of an electrical accident that might occur. Explain your answer. Do you think this is a good example? No? Why? Yes? Explain. And state one example of the cause of a short circuit. State one example of the cause of a short circuit. Write your answer in your notebook. Okay, that's all for today. So hopefully you have updated your notebook Okay, and you can always come again and watch again the video and update your notebook. Okay, I think that's all. Okay, thank you. See you around, and please bring your brochure.